15, starting with oral presentation 21, Ector County, Texas, Team 4, which is a Mission 13 flight experiment.
Good afternoon. We're from Nimitz Middle School in Ector County, Texas. Our research proposal is the activation of sea sporogenes, a novel cancer treatment in microgravity. The co-principal investigators are Miriam Akram, Sydney Richardson. Co-investigators are Ava Brower, Aiden Gomez, Mason Leet, and John Machado Torres. Teachers facilitators are Ms. Torres and Ms. Smith. Professional advisors are Dr. Natalia, Dr. Fleming, Dr. Lee, Dr. Gandhi, Dr. Lombard, and Dr. Bapodra.
Isn't it amazing that a bacteria found on Earth's surface could one day save the life of an astronaut in space? Many astronauts get diagnosed with colon cancer, commonly caused by the radiation. Many astronauts get diagnosed with colon cancer caused by the radiation in space. One cure for colon cancer is Clostridium sporogenes, a gram-positive anaerobiotic rod-shaped bacteria. The concept of this study is to find out how Clostridium sporogenes react to the microgravity of space.
Cancer is the second leading cause of death globally, with an estimated 9.6 million deaths in 2018. Thankfully, scientists are working non-stop to find a cure. One of the ways of almost curing cancer is using bacteria, specifically a bacteria in the genus Clostridium. An important characteristic of these bacteria is its ability to germinate the cancer cells and eradicate treatment-resistant hypoxic tumors in various experimental models. Bacterial treatment is an overall more natural way of going about killing the cancerous cells because chemotherapy and other cancer treatments have side effects that the bacterial treatment would otherwise not have. The significant side effects of the chemotherapy and other pharmacologic treatments would be very difficult to manage in space.
We predict that sea sporogenes will activate at room temperature in a microgravity environment in space. This means the sea sporogenes will undergo its regular life cycle in microgravity. This is the first step to testing sea sporogenes as a possible treatment for cancer on long space voyages.
We will be conducting this experiment in a Type 3 FME mini lab. This lab will be consisting of 2 stoppers, 2 clamps, and 3 sections. In our first section, we will be having our Clostridium sporogenes group A. In our second section, we will be having our formalin. After 48 hours in space, when group A is fully activated, we will release clamp A. We will mix both of the fluids to observe how much the bacteria had grew in the past 48 hours. In our third section, we will be having our Clostridium sporogenes group B. Group B will not be touched and clamp B will not be touched to see how far the sporogenes can go in space in its life cycle in the microgravity environment. The group B is our central volume.
And here is our ground truth timeline. To start, the ambient temperature will activate the spores. Then, approximately 48 hours later, the spores should be activated. At that point in time, we will unclamp clamp A and gently shake the vial for 30 seconds to thoroughly mix the sea sporogenes with the formalin to stop it from growing. The third section in the tube will serve as a control so we can compare the sea sporogenes that grew in the first 48 hours to the sea sporogenes that grew throughout the whole flight, including on the way back home to Earth. 4 to 6 weeks later, we will place the sea sporogenes under a microscope to count how many had fully activated and completely left the shell, how many were still partially encapsulated and didn't make it all the way out, and how many were still dormant and didn't leave the shell at all.
Thank you for your time and have a great day. Any questions?
Hi, my name is Jenna from iForward in Grantsburg, Wisconsin, and I was wondering if, I'm going to probably say this wrong, but sporogens, sea sporogens, is that right? Not really, kind of? Okay, we'll go with it. Okay, close enough. So are they currently FDA approved? Like, so are they allowed for treatment, or are they trial treatments on Earth?
So from our understanding, the sea sporogenes have been used for treatments in animals, and I think they've been used for some human treatments, but I'm not entirely sure.
Okay, thank you.
You're welcome.
Hello, I'm Heather from Annapolis, Maryland. I wanted to ask, how did you come up with your idea? It was a really great idea. I'm just curious how it came to you.
Well, we were always interested in ways to help people, and our first thought that came to us was cancer. So we were first thinking of a anaerobic pathogenic bacteria called Pseudomonas, but we didn't have, it was too expensive, so we decided to go with a different bacteria, and we found Clostridium sporogenes, which can be used for the same purpose. And we thought this might help for future generations, and it might be the first steps to be colonizing on Mars.
Wonderful, thank you.
You're welcome.